All right, here's problem 4 off the spring 2016 Math 213 final exam. In this problem, we're dealing with constructions. So I'm supposed to construct a kite by following the steps below, and I'm supposed to explain my process. Maybe I'll just describe it in words. So the first step here says connect points B and C with a straight edge. Not a whole lot of explanation needed there. Take a straight edge and you connect the two of those guys. Then show how you construct the line L through point A perpendicular to line segment BC. So that was one of your constructions. Anytime you have a point not on a line, you can construct a line that is perpendicular to this line that goes through this point. And the way you could do it is if you first put the pointy end of your compass here and the drawing end anywhere on this line. Maybe I'll stick it right here. I could draw this little arc. Sure. From this point, I could draw this little arc here. And that'll define a point here and a point here. And then I can take those 2 points and draw the perpendicular bisector of that line segment. And that'll be guaranteed to go through the point A. So the way you can do that, if you put the pointy end here and the drawing end here, you can kind of swing up this arc like that. And you can swing that arc down so it looks something like that. And then do the same thing, the pointy end here and the drawing end over here. Let's try to draw that a little bit more accurately. I don't know how much better that is, but fine. It'll look something like this, and it'll look, whatever, something like this. And you'll say, whoa, those arcs intersect at 2 points, down here and exactly here. And if I connect those two with a straight line, almost. I'll get a right angle right here. So for part A, I guess I've shown how I can draw a line through A perpendicular to that line segment BC. Now I want to construct point D at the appropriate place on line L. So line L was the one that I just drew, and I want to put a dot somewhere on this line so that ABCD will be a kite. So you can put it anywhere on this line. I'm going to put it down here. This is D. And the way I can make sure I have this point, it'll end up being exactly the intersection if I drew my arcs with the pointy end here and the drawing end here, but you didn't have to draw your arcs there. So in case you drew them differently, what you could do is put the pointy end in the point of intersection, and then put the drawing end up here, and if you draw a big circle all the way around like this, it'll intersect line L at a point that forces this side length to be the exact same as this side length. And that'll give me ABCD. And so now what I'm supposed to do is explain how the construction guarantees that ABCD is a kite. Okay, so if I connect this here, here, and here, my claim is that I have a kite. The way you can see that is this point has to be equidistant from here and here. Because this is the same and this is the same, and these angles are the same, and I can think about this triangle, I don't know, maybe I'll put an E in here. Triangle AEC is congruent to triangle DEC, and therefore this side length is the exact same as this side length. And by the same logic, triangle DEB is congruent to triangle AEB, so therefore this side length is the same as this side length. It turns out that this is the same as this as well, but you end up not needing that. This is more than just a kite. It ends up being a rhombus. But you end up not needing that. All you need to know is that this is a kite. And to make it a kite, I say I have 2 different pair of adjacent congruent sides. It turns out it's more than a kite. It's a rhombus, but I don't need to know that. All I need to do is explain why it's a kite. And the reason it's a kite is because I have 2 pair of adjacent congruent sides. I guess that was it for this problem.